In this video we're going to look at how we can work out the formula of ionic compounds. Now to do that we have to know the charges on the ions that are present. And the best way to do that is to look at the periodic table, because the periodic table tells us everything if we know how to read it properly. So a quick recap of the periodic table. Groups in the periodic table go down. So we've got group 1 on the very left hand side, group 2 here, group 3 here, group 4 here, group 5, 6, 7 and 0. If that doesn't make sense to you, just have a look at it on a proper periodic table very quickly. Here's a proper periodic table. So group 1 is this group on the very left hand side here, and I'm saying that's group 1 there. Group 2 is next to it, and I'm saying that's group 2 there. Group 3 here, and I'm saying that's group 3 there. You get the idea? Okay, so now the group number on the periodic table tells us the number of electrons on the outer shell. So if it's in group 1, it's got 1 electron in its outer shell. If it's in group 2, it's got 2 electrons in the outer shell. In group 3, 3 electrons in the outer shell. Group 4, 4 electrons in the outer shell. 5, 6 and 7. The group number tells us the number of electrons on the outer shell. In group 0, the outer shell is always full. So it doesn't have 7 electrons in the outer shell. The outer shell is always full of electrons. Okay, so now the important bit, the charges on the ions. If it's in group 1, it's got 1 electron in its outer shell, therefore it's going to lose 1 electron, therefore it's going to form a 1 plus charge. Okay, we really should write number 1 before it, we just don't because we're chemists. Everything else that doesn't have a 1 plus charge, we must put the number before it. It's not enough to say positive. Group 2, 2 electrons in the outer shell, therefore it's going to form a 2 positive charge. Group 3, it's got 3 electrons in the outer shell to form an ion, it's going to lose 3 electrons, so it's going to form a 3 plus charge. Group 4 doesn't form ions. Okay, group 4 is would bond covalently. It would form 4 bonds, because it's got 4 electrons in the outer shell, it needs 4 to fill its outer shell. Right, let's go back the other way. Group 0 don't form ions at all because the outer shell is always full. Group 7, got 7 electrons in the outer shell, they want to gain 1 electron, they want to gain 1 negative charge to fill their outer shell, so they've got a 1 minus charge. Group 6 want to gain 2 electrons, electrons negatively charged, so they're going to form a 2 minus charge. Group 5, a 3 minus charge because they want 3 electrons. So the periodic table tells us the charges of the ions. That's important. Okay, so trend for metallic ions in group 1 and group 2. Group 1 form a 1 plus charged ion, and group 2, let's make that one a bit clearer. Group 2 form a 2 plus charged ion. Trend for the non-metallic ions in group 6 and group 7. Okay, so group 7, the halogen group. Group 7 form a 1 minus charged ion. And group 6 form a 2 minus charged ion. Right, now that is absolutely essential if we're going to work out the formula for ionic compounds. Okay, so what I've done here, I've given you some charges of common ions, okay, but if the element involved is not in that table, all you need to do is go to the periodic table, find out where it is. For example, if the element is in here, it's going to form a 2 plus ion. If the element is in here, it's going to form a 2 minus ion. So if the element isn't in that table, we can find it from the periodic table. Right, what we're going to do now is work out the formula of these compounds. These are all ionic compounds. They contain a metal and a non-metal. The metal is positively charged, the non-metal is negatively charged. Okay, for example, sodium fluoride. What you have to do, find sodium and fluorine in the periodic table or in the table above, I really don't mind. Okay, sodium is in here, it's group 1, it forms a 1 positive charge, so you have to look at the periodic table. No other way to do it. Fluorine, here, group 7, therefore it forms a 1 minus charge, F minus. Now, if these charges are balanced, because in a compound the number of positive charges must equal the number of negative charges, if they are balanced, the formula is simply a 1-to-1 ratio, the formula is NaF. That's that one done. Next one, lithium oxide. Okay, find lithium on the periodic table. Lithium here, group 1, forms a 1 positive ion, Li+.
Oxygen here, group 6, that needs 2 electrons to fill its outer shell, so it's going to form a 2- ion, so it's going to be O2-. Right, the question you have to ask yourself now is, are there more positive charges or more negative charges? The answer is there are more negative charges. There's 2 negative charges. This formula is not LiO because these charges need to balance out. So to balance it out, we're going to need more positive. Let's draw another lithium there, Li+. Now ask yourself the question, are there more positives or more negatives, or are they the same? Well, I've got 2 positives, I've got 2 negatives. So let's now count the number of ions to get the formula. 1 lithium, 2 lithium, 1 oxygen. So the formula therefore is going to be Li2O. Okay, so the charges have to balance out. Calcium oxide. Okay, no way to do this other than looking at the periodic table. So many times you ask to balance a symbol equation and people just make up the formula. You can't make up the formula, you have to look at the periodic table. Calcium, group 2. Oxygen, group 6. So calcium, 2+, oxygen, 2-. That's what the periodic table tells us. So that's going to be Ca, 2+, O2-. Let's make that clearer. Ca2 plus O2-. Ask yourself the question, are there more positives or negatives, or are they the same? Or 2 positives, 2 negatives, they're the same. You've got the same number of positives as negatives. So the formula is simply CaO. Okay, it's not Ca2O2. That's not right. Okay, just the number of positives and negatives have to balance. Ammonium chloride. Well, ammonium is not on the periodic table because that's a more complex ion. So we can look at the table above here. Ammonium is NH4+. Okay, NH4+. And the chloride ion, you can look at this table if you want to. It's on the periodic table as well. Chlorine is group 7. It's in the table there. Chloride, Cl-. So, are the number of positive charges and the number of negative charges the same? Answer, yes. You've got 1 positive and 1 negative. So the formula, therefore, is just simply NH4Cl. A lot of times when people write this out, they get it wrong because they just write NHCl. That's not right. The NH4 ion, the whole NH4, so nitrogen and 4 hydrogens, when that's all together, it carries a single positive charge. So you must write that 4 there. Okay? We'll deal with how we deal with more, if we have more than one of these complex ions, in just a moment. But the nitrogen and hydrogen, nitrogen with 4 hydrogens together carries that single positive charges. And we've got 1 positive charge, 1 negative charge, so we have to write the whole thing out. NH4Cl. Right, Roman numerals. When you're given Roman numerals, that tells you the charge on the positive ion. So transition metals. We didn't deal with those a moment ago. If they're in this group here, they can exist, and the posh phrase is in more than 1 oxidation state. What that means is iron here could be Fe2+ or Fe3+ or Fe6+. You don't know. You just don't know. Okay? Unless there's a Roman numeral after it, and then it tells you. So that means Fe2+. Oxygen is not a transition metal. That's in group 6. Okay, everything in group 6 forms a 2 negative charge. Group 7 was 1 negative, group 6 is 2 negative. So that's going to be O2-, O2-. So, question, are these the same or are they different? Answer, they are the same. So the formula is simply FeO. Right, iron 3 oxide, a bit more complicated. This is where it starts to get a bit more fun. Okay, so that's that 3 there, that Roman numeral 3 tells us it is the Fe3+ ion. It's got 3 positive charges. Oxygen, we just saw it a moment ago in this group here. Sorry, this example here. Oxygen is in group 6, it forms a 2- ion, O2-. Right, 2 ways to do this. What I'm going to do is I'm just going to write this out down here to make it a bit bigger just for a second. Fe3+, O2-. Now, first off, ask yourself the question, do you have more positives or more negatives? The answer is we have more positives. So what do we need more of? We need more negatives. Let's draw out another O2-. This is the first way of doing it. Now ask yourself the question, do you have more positives or more negatives, or are they the same? Well, I've got 3 positives, I've got 2-, 4-. I've got 4- and 3 positives, so I've got more minors. So if I've got more minors, I need more positive. Let's draw another positive. Fe3 positive. Ask yourself the question, do I have more positives or more negatives, or are they the same? Well, now I've got 3 plus, 6 plus, 6 positives, and now I've got 2 minus, 4 minus. So I've got more positives, so I need more negatives. So I need another negatives over here, O2 minus. Then the final question, as it is now completed, do you have more positives or more negatives, or is it the same? Well, I've got 6 positives, 3 plus, 6 plus, and I've got 2 minus, 4 minus, 6 minus, 6 minus, it's the same. So count up, I've got Fe2, 1, 2, O1, 2, 3. I've got 2 ions. I always think that's an interesting phrase to say. Fe is iron, and of course a charged atom is an ion. So I've got 2 ions, and I've got 3 oxide ions. So the formula is going to be Fe2O3. Fe2, 1, 2, 1, 2, 3 oxides. I said there's 2 ways to do it. That's the way to do it. It's a bit more long-winded. Personally, I've always had quite a good grasp for numbers. So it was Fe3 plus O2 minus. So I'm just asking myself, what's the first common multiple of 3 and 2? That's what I'm asking myself. The first common multiple of 3 and 2 is 6, so I know I'm going to need 6 positives. So how am I going to get 6 positives with a 3 plus? I'm going to have 2 of them, so it's going to be Fe2. I'm going to have 2 of those straight away. How am I going to get 6 negatives with a 2 minus? I'm going to need 3 of them. So you can just look for common multiples, and it gets you to the same place. Or you ask yourself the question, do I have more positives, more negatives, and just keep adding until you get to the same number. It really doesn't matter how you do it. Right, time's marching on, so let's do a more complex example. Magnesium nitrate. Okay, so magnesium is in group 2 of the periodic table, so that's going to be Mg2+. Okay, nitrates. Now this is one of the more complex ions. Now you need to learn some of the complex ions. I've given them here for you, but nitrate is NO3 with single negative charge. Hydroxide you need to know as well. Sulfate you need to know, and quite possibly carbonate. These are worth learning. Okay, you can't look at the periodic table, you just need to know those. Okay, so it's Mg2+ and nitrate NO3-. Right, do you have more positives or more negatives, or are they the same? You've got more positives, so we need another negative. So we need a whole nother nitrate ion, NO3-. Now to write this, okay, Mg, there's one of those. Nitrate, now there's 2 nitrate ions. Now when we have 2 nitrate ions, we write nitrate out, NO3. It's still NO3. Some people like to write NO2 there. Don't do that. Okay, NO3. And we need 2 of them. So the way we do that is we put a bracket around the nitrate ion and we put 2 outside. That's now correct. So we use brackets when we have more than one of these complex anions. The one above here, okay, I only had 1 ammonium, so there's no brackets there because there was only 1 of them. This one here, there's 2 nitrates, so I do need brackets around the nitrate, and I put the 2 outside it. I've got time, I think, to do maybe 1 more bracketed one. So which one should we have a look at? Shall we have a look at... Let's do magnesium hydroxide. Okay, again, magnesium, Mg2+. Hydroxide, back up here now. Remember, you just have to learn these. You can't look at the periodic table for these complex anions. Okay, it's OH-. So you do need to learn that hydroxide formula, OH-. Do you have more positives or more negatives? The answer is you've got more positives, so we're going to need whole nother hydroxide ion, OH-. Okay, so this time that now balances that out. 2 positives, 1, 2 negatives. Okay, a lot of people would like to write MgOH2 with a 2 down there. That's wrong. Don't do that. We've got 2 of these more complex anions, so we have to use brackets. Have a go at the rest on your own and speak to your teacher if you want them to check them.